Sectors for cork products, cork properties, future trends for cork. Chapter done by Wrocław University of Science and Technology. This is IO2 Educational Materials Lessons Presentation. Introduction to cork sectors. Natural cork, the main product of unique forest ecosystem in the world of cork oak trees, is a material with unique properties that can be reused in any form, non-toxic, durable, and wear-resistant. Cork effectively binds atmospheric carbon dioxide, which is essential especially concerning global warming. The world of science and business values cork for its extraordinary physical and mechanical properties that can be synergistically used for sustainable development of economy and industry. Cork is a versatile and sustainable material with a wide range of uses in many industries. It is naturally waterproof, fire retardant, and environmentally friendly. Over the years, its use has grown exponentially as cork products have become increasingly popular in home, commercial, and industrial consumer markets. There are several sectors that utilize this material, including construction, flooring, isolation, and ceiling solutions. As consumer preferences have shifted towards more sustainable products, the demand for cork has skyrocketed, and the sector is expecting to further expand in the near future. In recent years, cork industry gaining new fields of industry. Cork material as a material has fascinating properties which can significantly improve current designs. Fields of cork material applications are as wide as stoppers for steel and sparkling wines and spirits, automotive and railways, micromobility, aerospace, sport, hand device interface finish, architecture and design applications, including floors and wall coverings, construction and infrastructure, such as cork underlayment, and fashion and furniture. At this point, it should be noted that the successful introduction of cork material in existing products could be considered only by its presence on the market. Prototype or custom solutions not in a mass production cannot be regarded as a valid application of the cork material because they are public or private funded research program or overpaid, highly customized product. Therefore, the discussion of the currently introduced cork material is limited to the products offered on the market. In this paragraph, cork material is considered as raw cork and derivative cork materials such as polyurethane-based cork conglomerate or other cork-based composites. Cork is one of the most versatile natural materials. It has a wide range of application from a single bottle caps to specialized aviation heat shields. It is light, compressible, elastic, durable, chemically and biologically resistant, non-toxic, flammable, retardant, practically impermeable to the gases and liquids, shows good thermal and acoustic isolation properties, and it is also excellent vibration and electric isolator. The unique cork properties result from its honeycomb-like cellular structure. Cork sectors. Stoppers for the still and sparkling wines and spirits. About 70% of obtained cork is used as bottle stopper. This is the biggest sector for cork production sector. Automotive and railways. Cork is used for making various seals, especially in cars and for the interior finishing of vehicle cabins. Its flexibility, resistance to the heat and impact, and pleasant texture are used. The transportation industry has a growing demand for the materials with high strength to weight ratio. Aerospace. Cork is assumed as a heat protection shield material for the test mission where spacecraft will re-enter the Earth's atmosphere. During their re-entry, each spacecraft experiences high thermal loads due to air friction against spacecraft structure. During Space Shuttle era, space shuttles were covered with ceramic panels. One of the hypotheses is that cork material might be used for re-entry shielding. Low burn regression and high thermal isolation properties in high temperatures have a great potential for cheap and non-complicated manufacturing heat shields for re-entry. Sports and hand device interface finish. Cork composites are prepared from agglomerates from various granulation, usually 0.5 to 40 mm grain size. The granules used are usually waste from the production of plaques. The granules are mixed with a reactive polymer and pressed at room temperature or mixed with the polymer binder and pressed at elevated temperature under pressure to produce cork composites. The intended properties of finished products depend on the dimension of cork granules, its mass fraction in the composition. It might be up to 90% by mass, the type of the binder, polyurethane, phenyl formaldehyde resins, etc., and the packing density of the agglomerates used in the production process. Sport and hand device finish. The continuing section, the block of the cork agglomerates produced a laminate shaped according to the planned dimension and smoothed. They are used to obtain panels, boards, shoe insert, handles, grips, something what you can see on the pictures. This is a hand device interfaces where humans are touching devices with a nice and pleasure cork finish. Architecture and design application including floor and wall coverings. The usage of the cork in architecture is widespread. Due to its attractive structure and positive experience for human hand, cork is very common in any type of architecture, from household accessory to major decorative floor in large building and artistic installation. The construction industry is the second largest area where natural cork is used in soundproofing walls, suspended ceilings, wallpapers, flints, floors coverings in buildings, and isolation in industrial cold rooms. Cork is characterized by small thermal conductivity, sound propagation speed, and acoustic impedance, making it suitable for use as a material for thermal and sound isolation. The cork composite used in this way contain 90 to 95 cork weight in polyurethane matrix. Fashion and furniture. Cork material, recognized as a green and sustainable material, is widely used in the fashion industry. In this field, trends play significant role, which is why the quantity of application will vary in the following years. Fields of application in the fashion industry are decorative, cork fabric, liners, shoemaking materials. In this sector of economy, where manufacturing companies make strong declaration about ecological and sustainable material usage, it is expected that cork material with other natural-based materials will be more present. And right now we will switch to a second section of this lesson presentation, Introduction to Future Trends for Cork. And we'll focus on the cork product driven by unique cork properties or combination of these properties. Cork-based sandwich materials. This is a material which has aluminum skin with cork agglomerated core. Core materials are divided into natural or synthetic core material, such as wood, plywood, hemp, straw, or cork. The bottom left panel, which you can see here, is created with the balsa wood core material with perpendicular grain direction to the panel surface. Two other panels are created with the synthetic cores that have aluminum honeycomb and the foam cores. The rest of the panels has a cork cores. It is essential to mention that in the sandwich structure, volume of the core material may be up to 95% of entire material, thus ensuring a high usage of degree of eco and sustainable materials for the core is crucial. Skin panels, usually made of aluminum, have a low ecological impact due to their high recycling capability. Using natural materials for this purpose make it possible to create high-performance, lightweight structure with a low carbon footprint. And this is a first case study, a case study for the lightweight panels which are suited for the fast rearrangement system for passenger train interior. The project assumption and design. So the lightweight panel structure are a good choice for quick rearrangement of the vehicle passenger space. It might be used for the temporary walls, floor, and ceilings. These kinds of the panel usually are the sandwich structures. Outer panels are made of the side of skin material, ensuring rigidity and carrying most of the loads, while inside the core material is lightweight material and has a support role for the skin material. Core material is glued to the skin panel, prevents buckling. At this point, it should be noted that neither skin panels nor core material can withstand even a small portion of the loads that properly glued sandwich material can, mostly due to the loss of stability, usually referred to as a buckling. Okay. And as a continuing of this case study, I would like to introduce finite element analysis, which allows determining stress in material and deformation of examined geometry against applied loads. Usually, finite element analysis requires the following step: cleaning of the original geometry by removing unnecessary features from the geometry, preparing discrete model, what you can see on the left picture, by convert from by default infinite continuous geometry into discrete elements, applying interaction mechanisms such as contact ties or gluing connections, use boundary conditions and forces, and set up simulation parameters, and then performing the proper simulation. And the results of the proper simulation, this is something what you can see on the middle and the right picture. And this is in the middle one, the formation of the temporary walls for the passenger train under applied loads in this particular scenario. And for the same applied loads on the right one, you can see the internal stresses in a material. Okay, moving forward to the second case study. Here it's a case study of the frontal protection system. So this in this chapter we introduced the reader to the case study from the assumption to the final product, and in which the author present the approach to use the cork composite in the automotive sector. The research aimed to prove the safety of vulnerable road users by developing and implementing a frontal protection system which mitigates injuries during an accident with a vehicle. Okay. So, due to the trend for the purchase of SUVs in Europe and their more frequent participation in an accident involving pedestrians and cyclists, SUVs are commonly used in the cities. The authors identified a need for safe frontal protection system. The designated FPS provides pedestrians and cyclists with appropriate, supported by numerical test kinematics after collision with a vehicle, while at the same time contribution to the reduction of injuries through the use of the appropriate energy absorbing materials. In example, natural materials, cork and composites like carbon fiber. As a part of the research, multivariate numerical models and physical prototypes were created and tested. This implementation of the combination of cork with the carbon fiber allow auto to substitute steel and aluminum alloys in this frontal protection system. It should be emphasized that development of the new FPS not only enhanced vulnerable road user safety, but also improved the design of the vehicle front end. Okay, so there is a schematic diagram of pedestrian kinematics after a collision with SUV. On the left-hand side, you can see the collision kinematics without a safe frontal protective system, while on the right one you can see the kinematics with the frontal protective system fitted to the vehicle. It changed a lot the kinematics of the accident, which prevents a vulnerable road user from suffering serious injuries, while we unnecessarily has to lever the level of the injuries, while we are assuming that the head and spine injuries are more important to the survivability than the injuries of the legs or hips. Okay, at this point, reverse engineering and design steps has been taken as a subsequent stage. Throughout 3D scan, using a 3D scan of the vehicle with the front belt removed was performed in order to recognize the mounting elements for the frontal protection system. The final results of the measurement is the combined point cloud from all scan, which is the basis for recreation the vehicle front and geometry. The obtained scanning tolerance after combining the point cloud was approximately 1 millimeter. It is the design basis for the modeling frontal protection system. Further detailed design works were carried in computer-aided design software. And here is a simulation and analysis. By analyzing the course of the simulation presented below, significant improvement in kinematics and biomechanical parameters of the dummy can be observed in relation to the vehicle not equipped with FPS. The greatest deflection in the knee have been significantly reduced, which is also confirmed by the test of biomechanical criteria. The head and upper body remain stationary for the certain moment under the force of inertia, but the given rotation makes it possible to project the head on the vehicle's hood. And we can observe a reduced deflection of the dummy cervical vertebrae, which reduce the likelihood of serious injury. The course of the dummy kinematics make it possible to use the other systems that improve pedestrian safety, including a lifting mask with additional gas cushioning, such as an airbag to protect the head. The rotation given to the pedestrian also causes the pedestrian not to experience the maximum acceleration of the whole body in a short time. In addition, the head acceleration does not exceed the standard parameter, and among others, the head injury criteria, which in critical value 1000 means serious injury close to the death, while in simulation this parameter was below 100. Okay, the various types of the cork were tested. In example, natural cork, agglomerated cork composite with polyurethane, and cork filled with non-Newtonian fluid. Due to the minimization of the head injuries during the multiple impact, especially in motorcyclist case, different configuration of arrangement of different cork connected with the glue were also investigated. Finally, a material model was developed which will be validated during the experimental test. For the sake of FPS safety properties, the use of the cork materials for the energy-absorbing FPS filling was the most reasonable choice. However, two types of reinforcement covering the cork material were carbon or glass fiber. The carbon is composed of structures almost entirely chemical, similar to the graphite. They are characterized by high resistance to high temperatures and chemical and good thermal and electrical conductivity. In addition, carbon fibers' advantages include low density, high strength, and the ability to dampen vibrations. And this is a look of the final design of FPS mounted on the Toyota Land Cruiser vehicle and Ford Transit. Conclusions of the case study. The study aimed to improve the safety of pedestrians and cyclists by developing and implementing systems based on natural energy consuming material. In this case study, a ECOCORK FPS was designed and numerically tested. The carbon fiber composite is increasingly used in the automotive industry due to its low mass density and high strength. Thanks to that, FPS made of carbon fiber may effectively protect the front elements of the vehicle. Additionally, the core energy absorbing capabilities can reduce injuries sustained by the pedestrian during an accident. So, the summary, cork is a remarkable natural raw material with unique combination of synergically reinforcing properties. It is suitable for various applications, from the typical bottle stopper to sophisticated thermal isolation shields for engines and rocket tanks. Now, knowledge in modern material engineering enables the continuous expansion of the application area of cork and its composites, and research on innovative cork application is also continued. Cork is a precious gift of the nature that must be treated with respect and used as widely as possible, sustainable and ecological. And this is a literature based, which is a basement for this chapter. This is a part 1, this is a continuation, part 2, part 3, part 4, and part 5 of the references to this chapter. Thank you.